shall we? So, good morning to those of you on the West Coast. Good afternoon to those of you joining from the East Coast, and good evening to anyone joining us from Europe or stations further east. Thank you for joining this, the fourth of our regular series of short courses on pumping topics. This one will last about 35 to 40 minutes, allowing us time for a Q&A session after the presentation. Those of you who attended any of the earlier sessions will know that we are deliberately steering away from product presentations and towards educational content, addressing a different pumping topic in each one. But having said that, please forgive me 4 or 5 brief slides to remind you who we are and what we do. Well, we are Roar Pumping. We are clearly now a global player, quite a large company up there with the big boys. With over 70,000 pumping installations worldwide, over 70 years of experience, and manufacturing facilities in 10 countries, and indeed 5 different continents. 1, 2, 3, 4, 5 continents. So yes, we think we have a global presence. We're big in all the industries that you guys are in: power, water, chemical, industrial, and particularly for this audience, I think, the oil and gas. We have a wide range of pumps, as you'd expect: single stage overhung, foot mounted, centerline, ANSI, ISO, general purpose, or API 610. Between bearings pumps, axially split or radially split, API 610. Horizontal multi-stage pumps, again, axially split or radially split, double case. Vertical pumps, multi-stage or large single stage pumps. General purpose, API 610, double case or single case, and also submersible motor driven. We also have a range of positive displacement pumps and magnetic drive pumps, and we have package systems, fire systems, and decoking systems. Well, that's the end of the commercial. Now let's get back to the subject for today. This seminar is going to look at selecting the right pump for the application. It's aimed at process and mechanical engineers and consultant engineers who are specifying pumping equipment, as well as to applications and sales engineers who are selecting and quoting them. What we're going to achieve, I hope, is that you develop an understanding as to which type of pump is appropriate for different applications. We'll look at such topics as when to transition from an OH2 to a BB2, when to consider a VS6, barrel pumps versus horizontal split case multi-stage. We will be covering the main range of pumps used in the oil and gas industries. I'm not going to try to cover chemicals, water, general industrial, or fire. There's a limit to the useful information I can impart in a 40-minute session. There are an awful lot of detailed slides here, primarily range curves. Now, I don't expect you to take them all in, but I would suggest that you print the curves off, laminate them, put them in your top drawer for easy access. We will be holding a Q&A session at the end. Unfortunately, as most of you know, the nature of a Zoom format makes it very difficult to have a fully interactive Q&A session, especially with so many attendees. We are on how many at the moment? 115 at the moment, attendees on board at the moment. And we had 180 this morning, and we've had 200 attendees for some of the earlier sessions we've had. So we won't be able to do a fully interactive one, but we'll do the best we can. Please use the Q&A facility at the bottom of your screen to ask any questions or make any comments. I'll address those that I can answer quickly at the end of this session, and those that need a more detailed answer, I'll answer in writing in the coming days. As I mentioned before the session started, we are recording the session and we'll make it available to all attendees as a YouTube link, as well as by emailing you a PDF version of the slideshow. Now let me get back onto the show. And here we go. Okay, let's look at a couple of scenarios. Scenario A, you are a process engineer or mechanical rotating equipment engineer, and you have the preliminary process data for a pump duty. For example, here we go, 200 cubic meters an hour, 200 meters head, 5 meters NPSH, specific gravity of 0.7, temperature 150 C, and 50 cycle site electricity. My apologies that I haven't changed this into American units for this Western Hemisphere presentation. You'll get used to using cubic meters per hour. Anyway, here's your duty. So the question you ask is, what sort of pump will this be? Now, this is presumably an early feed study stage, and you probably don't want to waste the pump vendor's time by asking. So you go with your gut and you say, it's probably an OH2. Are you right? Well, I'm going to give you the tools to be able to check this out and save you getting into trouble. That's scenario A. Scenario B, well, it's the same situation, but from the opposite viewpoint. This time you're a salesman or applications engineer, and your customer, the aforesaid process engineer in scenario A, has asked you, what sort of pump do I need for this duty? Just a quick check, don't spend long on it. So what do? You probably plug it into your pump selection program and see what it spits out. Well, I did that. The program defaults to listing possible selections by efficiency, the most efficient ones first. So the first 3 compliant selections, 1, 2, 3, are BB3 pumps, actually split case multi-stage pumps. Next, we have a couple of BB2 pumps, well back on their curves, as you can see. Then we get a BB2 two-stage pump. And finally, in 7th and 8th position, we get to an OH2, which is what we were expecting it to be in the first instance. Well, what did you do as the applications or sales engineer there? Did you tell your customer, it's a 3-stage BB3. It's a nice selection, bang on best efficiency point, and it's 76% efficient. Well, I hope you didn't, because it blatantly isn't a BB3 selection. So what do we learn from this? We learn that pump selection programs are stupid. They're a great tool, but a poor master. And finally, Always know the pump you expect to see before you use the pump selection program. And that's what I'm going to help you to do, to give you the tools to be able to check out before you go in and plug this into a selection program. You know what you're going to be looking for, what to expect. And here is what you do. You start with the least expensive option, the OH2. When you think about it, 200 cubic meters an hour and 200 meters, it feels like an OH2, doesn't it? And anyway, it's a good place to start on any search. So here we have the OH2, single stage, single suction. It's the refinery workhorse. It's not great on NPSH, and it's not great on high suction pressure duties. But here are 4 range curves. This one, 2-pole 50 Hertz, 4-pole 50 Hertz, and this will interest you more, you guys on the Western Hemisphere. 2-pole 60 Hertz, and 4-pole 60 Hertz. As I suggested, print them off, laminate them, and put them in your top drawer for ready access. We'll go back to the 2-pole 50 Hertz. And let's have a look and see if we have a selection for our specimen duty. 200 cubic meters an hour at 200 meters head. There, comfortably in the middle of the range. You can't read the pump size in this chart. Well, you can, if you zoom in enough, you can see approximately what size it is. But anyway, that's not the point of this exercise. Broad brushstrokes is the name of the game. We're looking at the big picture. What we can see is that there is very probably an OH2 that can do it. Now, never mind that this is a raw pump and range chart. This is a fiercely competitive market, and you'll find that most other manufacturers have very similar ranges. So if RP can do it, so can many of the others. But don't take my word for it. Here is the FlowServe published range chart superimposed on top of the raw pump and one. As you can see, very similar range. Looks as if FlowServe have an outlying pump that raw pumping doesn't have, but in the main area, pretty much the same area bound. Same thing for Sulzer. And again, for Gould's. I also have similar slides for Gabionetta, Apollo, Enseval, Finder, various others. And you'll see, you would see if I flash them up, that they're all pretty similar. These final 3 slides won't be in the final released presentation, by the way. So we've established that the flow and head falls onto an OH2. And having remembered that OH2 pumps aren't great on NPSH, we ask the question, do we have enough NPSH available? Well, I've made a simple NPSH suction specific speed calculator for you to be able to check this. All participants will get a working copy of this calculator when we send out this session's slides. It's just an Excel workbook. It's very simple. What this calculator does is it calculates the suction specific speed of the theoretical pump that meets your NPSH available with the normally accepted 1 meter or 3 foot margin. So you enter the data in here in metric units, or here if you're looking in US gallons a minute units. So we entered 200 cubic meters an hour, 2960 RPM because it's 50 Hertz, and 5 meters NPSH available. Now we see that the theoretical suction-specific speed of a pump to do this duty with a 1 meter or 3 foot margin would have a suction-specific speed of 12,759 in US units. Now, the industry has, for various reasons, most of them erroneous, set a maximum value of suction-specific speed of 11,000 in US units or 12,760 in metric units. Now, this isn't a subject that I'm going to go into today, but I will do so in session 5 on NPSH and suction-specific speed in 2 weeks' time. But nearly all the pump vendors have given up trying to fight this limitation and have designed most of their hydraulics to be within this 11,000 limit. So in this calculator, if the suction-specific speed shows up as being higher than 11,000, you get this warning message. It says, try a slower speed or increase the NPSH available. Or you can select a double suction pump, a BB2 pump, because that does have a suction-specific speed below 11,000. But it's considerably more expensive than a OH2. So let's go back and look at our options. Your options are, is there a 4-pole OH2 selection available? Remember, the program said, look for a slower pump, possibly. Well, we've selected a 2-pole and it missed on NPSH. So let's have a look and see if there's a 4-pole selection available. Here's the 4-pole curves, 200 cubic meters an hour, up to 200 meters. Clearly no. So the next thing we say is, can you find a bit more NPSH-A? Back to the calculator, I've increased the NPSH-A now from 5 meters to 6 meters, assuming if you can find an extra meter of NPSH. And this time, suction-specific speed 10,792 in US units, below 11,000. So you can be pretty sure that most vendors will be able to offer you an OH2 that will meet that duty. This depends on you being able to find that extra meter of NPSH. If not, the next option we have to look at is there a BB2 pump available? Okay, here's the BB2, top suction, top discharge. It's a double suction pump, so has lower NPSH required. Why? Because the flow comes down here, splits into two, half goes into this side of the impeller, half goes into that side of the impeller. Double suction. It has twice the impeller eye area compared with the equivalent over OH2, overhung suction, overhung single stage pump. So twice the impeller eye area, half the pressure drop on inlet into the impeller in round terms. And that is what NPSHR is. It's the pressure drop as the flow goes into the impeller. So let's have a look at a BB2 selection for this duty. 200 cubic meters an hour, 200 meters head. Possible, but not a good selection. It's about 60% of best efficiency point flow, and that's a non-starter. You just don't select a pump that far back on its curve. So we've looked and said, is there a 4-pole OH2 selection available? No. Bit more NPSH available? No. BB2 pump available? No. So we're left with, is an inducer acceptable? some customers will allow use of an inducer. That solves your problem. Is a higher suction specific speed impeller acceptable? Now, although most of the pump vendors have adjusted our hydraulics so that we have 11,000 suction specific speed pumps, we still have the old impellers that have a higher 12,000, 13,000 suction specific speed. They're still available. So we could offer them if that's acceptable to you. Or we select a VS6 pump. That's the vertical barrel pump, the low NPSH R. What you don't do is you don't select the 3-stage BB3 that I came up with in the very first beginning selection, because if you do that, you'll lose the project. Okay, I'll leave this example duty behind now. It's kind of served its purpose. It's shown the logical way to progress is to look at an OH2 pump first, then a BB2. So here are the BB2 range charts. Here's the one we just looked at, which is the 50 cycle 2-pole. This one is 50 cycle 4. This one is 60 hertz 2-pole. And the last one, 60 hertz 4-pole. Again, and as with all the curves I show you today, most vendors will have very similar ranges. We may have an outlying pump at the extremes that others don't have, or vice versa. But for the main area, within the bulk of the chart, we'll all have similar range coverage. Now, I just want to get this in perspective and go back to the OH2, one of the OH2 charts. The BB2 charts really fit in about here. Okay, so there's some overlap with the high end of the OH2, covers about there. Okay. Moving on. We're still in the BB2 range, this time 2-stage pumps. Again, top suction, top discharge. There's a sectional drawing of it. And let me show you the flow passage. Here's the suction. So the flow comes in through the suction, down this passageway, into the first stage, gets thrown out into this crossover, into the suction of the second stage, spun round and comes out here, which is here. Okay. Here's the range chart. This one, first at 50 hertz, gets you to about 800 cubic meters an hour at 600 meters. And at 60 hertz, and in gallons a minute this time, it'll take you to about 4,000 gallons a minute and 3,000 feet of head. Notice that double suction is available on some of the larger sizes to reduce NPSH. So we had a look and you couldn't get a suitable selection to meet your NPSH required with any of the OH2s or the BB2s. The next logical place to go would be for a VS6. These are traditionally used when you have very low, even 0 NPSH available at grade. Works on the basis that if you have 0 NPSH available at grade, here 3 meters or 10 feet down, you have 3 meters of NPSH available, or 10 feet of NPSH available. So we make this pump long enough by putting in 1 meter or 3-foot spool pieces in here to lower the first stage impeller sufficiently that you end up with sufficient margin to have your pump work. But this type of pump isn't just an NPSH saver, it's a space saver as well. It takes up about 20% of the floor area of a BB2. Well worth considering. It's also a cost saver. It's less expensive than a BB2, in particular because you only have one seal and one sealing system. So it's going to be less expensive than a BB2 with 2 seals and 2 seal systems. But unfortunately, civil engineers don't like digging holes. There can be good reasons for it, such as high water tables or groundwater quality. But if you can persuade them to dig a hole, you're saving costs all the way. Big uses for these pumps: light hydrocarbons, C2, C3, C4, condensate water in power stations, ammonia, liquid oxygen, liquid nitrogen. Here's a range chart for the semi-engineered or modularized price list pump, basically. And you can see 5,000 gallons a minute and heads up to 4,000 feet at 60 hertz. We also have an engineered pump range. Here's the engineered pump range. And this uses some big mixed flow and axial flow impellers. And we're getting here out to regions of 200,000 gallons a minute, 250,000 gallons a minute. So some very big pumps we can build. These would be very high flow, low head. Now we move on to axially split case pumps, type BB1 and BB3. They're most commonly seen as pipeline pumps for both oil and water pipelines. API 610 puts a limit on the use of axially split pumps. It says that you have to use radially split pumps if you're over 400 Fahrenheit, if your SG is less than 0.7, or if your discharge pressure is over 1450 PSI. What they're largely concerned about is leakage through and past the flat gasket that seals the upper case to the lower case. Now, these limits are very conservative, and API does accept that some manufacturers have excellent installation lists of pumps exceeding these limitations. And I'll go into that a little more when we look at the BB3 in just a minute. It's a very interesting subject. There's a lot of debate on it. And if you're interested, then have a look at this reference by the pump guru, Simon Bradshaw. So here's the axially split case single stage pump, our model ZM. And again, we have 4 slides. First one is 2-pole, and this time 50 and 60 hertz. So we can see that we are going in American units up above about 3,000 feet and flows up to 24,000 gallons a minute. Four-pole, 6-pole, and 8-pole. So as you can see, here we go. We're going to some very high flow pumps. The axially split multi-stage type BB3. Here it is. This is showing a 10-stage pump. It has back-to-back impellers, half of them facing one way, half of them facing the other way. So the flow comes in through the suction. The suction is like this one, but it's over here. Comes in into the first stage, across into the second stage, out into the third stage, fourth stage, fifth stage, comes out of the fifth stage into this crossover, and then into the sixth, seventh, eighth, ninth, 10th, and out of here. And the reason for back-to-back impellers is it balances the thrust. 5 facing one way, 5 facing the other way, you've balanced your thrust out. This thrust bearing is lightly loaded, and so it's a long-lasting workhorse of a pump. Here is the joint that API 610 is concerned about. Now, note how in our design we have these interstage bolts, which ensure gasket compression in this area is good. And so it prevents washover between stages, particularly at the center stage. Here is an example of a pump that doesn't have interstage bolting, and you can see the effect of washover here at the center bushing. Now, we're not unique in having this design. Flowserve has a similar design and have for many years. I recall when I was working for Flowserve, we frequently said to clients, look how many pumps in propane and butane service we have with this type of design. So it's a good way of progressing. You really don't need to go to a double case pump if you're handling propane at these sort of pressures. Here's the range chart for the smaller, lower head sizes. So 300 cubic meters an hour, 700 meters head, or at 60 hertz, we're talking 2,000 gallons a minute, 2,000 gallons a minute, and 3,000 feet, 3,000 feet. And the larger sizes, in US gallons a minute again, 6,000 gallons a minute and 6,000 feet. Finally for today, double case pumps, type BB5. When do we use these? Well, you use them when you have no other choice. High pressure, low SG, customer won't let you use a BB3 for low SG product. It comprises an inner case and an outer case. The outer case is the pressure boundary. The inner case can be a split case volute design, like a BB3, but more commonly, it's a diffuser design. The impellers can be inline, all facing the same direction, I mean, or back-to-back, as shown here. So let me show you the flow path again. It comes in here through the suction, into the first stage, second stage, third stage. It enters this passage and crosses over into the fourth stage, fifth stage, sixth stage, and then out the discharge. It's usually built as a cartridge pull-out design. You pull out the inner case and take that off to the workshop to be dismantled. I will probably be doing a session on BB5s in the coming months. Some amongst my planned courses still to do. Here is the range chart. So up to 6,000 gallons per minute and 13,000 feet of head at 60 hertz. Now this is where I'm leaving the session for today. We have covered the main range of pumps used in the oil and gas industries. I've not tried to cover chemicals, water, general industrial, or fire, because, as I said at the beginning, there's a limit to how much we can achieve in a 40-minute session. Now, I apologize that there were an awful lot of detailed slides. Again, I don't expect you to take them all in. I'm not going to hold a pop quiz. I'd suggest that you print the curves off, laminate them, and put them in your top drawer for easy access next time you have next time you're speccing or selecting a pump. Which brings us to the coming attractions. Our next session on Thursday, the 1st of July, that's in 2 weeks' time, is on NPSH made simple. Well, or simpler anyway, because it's the most difficult and misunderstood concept in pumping. And I hope that I'll be able to make it a little better understood than it frequently is. Again, there's going to be 2 sessions, one for the Eastern Hemisphere and one same time as today for the Western Hemisphere, you guys. Now, we're probably going to do a short break in these short courses during the summer holiday period of July and August, and we'll recommence in September. I have several subjects in mind to cover, and I'm going to add to this list in the following weeks. I'm leaving this meeting open for a little while now to allow you to post in the Q&A box, and I'll endeavour to answer those that only need a short answer here and now. Those that need a fuller answer, will be answered in the coming few days. Anything you think of later, come through to us. info@rawpumpen.com. Okay, info@rawpumpen.com. Our marketing team are standing by to direct your questions or suggestions to the best person to answer them. And they will be sending you the YouTube recording and the PDF of the presentation and the NPSH and suction specific speed calculator that I talked about. They'll be sending you those in the following few days. If you need a certificate of completion for this short course, then again, send us an email to info@rawpumpen.com and we'll do so. Now, let's get on with the Q&A. I can see we've had a few. We've got 12 Q&A questions here at the moment. Let me have a look and see what we've got and what I can answer. Where could we find and download the pump selection program? Is it free to install? So Vimal Engineer, yes it is, and you can go to the rawpumpen.com website and you'll find a link to finding it. I'll give you a bit more detail in a written response. Ahmed Metzena, some vendors fabricate pumps are equipped with an inducer. Yes, yep, that's a good way of reducing the NPSH required. They're not universally popular. They have some bad history. Certainly in the early design years, an inducer was perceived to work at its design point. Yes, it reduced the NPSH, but the NPSH curve was U-shaped. So once you got away from that design point, the NPSH was actually higher. Now, OH2 pumps are expected to work in a refinery right across their operating range, minimum flow to run out. So that means that inducers have not been popular over the years. Modern inducers are without doubt much better than the ones that were around 40 or 50 years ago, but they still have a bit of a bad name, and most vendors are not offering them as standard. Ahmed Metzner has asked again, what is the relationship between suction-specific speed and NPSH-R? I will go into this, well, come back in 2 weeks' time, and I am going to do a session that is specifically about that. But the short answer is the higher the suction-specific speed, the lower the NPSH required for the pump. So there, you will find that a lot of vendors still have available for you pumps with a suction-specific speed of 12,000 and 13,000. They have a better NPSH response than those that meet the limit of 11,000 suction-specific speed. So it's a matter of what the specification, what your specification allows. If it will allow you to exceed 11,000, fine. But a lot of them don't. Shell doesn't, Exxon doesn't, Aramco doesn't. A lot of specs do not allow more than 11,000. Vimal Engineer says, will you cover sealing systems in future training sessions? I do have in mind the possibility of doing mechanical seals and sealing systems in future sessions, yes. I think I'll need to come into a partnership with a seal vendor to be able to do a professional job on that. Ahmed Metzner again. Sometimes it looks like there is another criterion to take decision between horizontal pumps BB2 and vertical pumps VS6 for the vibration issue. I don't see why that would be. A vertical VS6 will meet the same vibration criteria as an OH2 or BB2. So that shouldn't be an issue. Rienzi Ramsahai, sorry, I've pronounced that all over the place. He said, are the previous sessions available via email or link? Yes, they are. If you would send an email asking for them to info@rawpumpen.com, our marketing people will be able to help you with that. Mohammed Rahman says, from the cutout view, it seems the outlet from each stage to the next stage is very narrow. Will that create any adverse effect in terms of erosion or any kind of other physical damages to the pump body or impeller? No, it might look as if it's small, but these pumps have been designed with finite element analysis, with the CFD. They are well designed for the velocities that they are experiencing. Lorenzo Pozos, sometimes customer requires an actually split case multi-stage pump with 0.4 SG. Do you have any option to modify the design to reach this requirement? Well, the design of BB3 that I showed you with the interstage bolting is good for a 0.4 SG. So the answer is modern designs are good for 0.4 SG. It would be an exception to API 610. You would have to be saying, yeah, it doesn't meet those pressure and SG requirements. But here's the installation list of similar pumps in similar duties, and you can sell it to your customer that way. Mohammed Rahman says, do you have any plans to have a session on pump seals and what type of seal plan should be considered during pump selection? Yeah, I think I covered that just now. Yes, I think I want to get together with a seal supplier and come up with a future session on that. Abigail Crow says, how can we register for the NPH seminar in 2 weeks? Very interested, first time attendee here, new grad at an EPC. If you received the invitation to this one, you will automatically get an invitation to the next one. If you didn't, then send an email to info@rawpumpen.com and ask to be put on the mailing list. Anand Ramdas, will you be covering structural or flow-induced resonance considerations in pump installations in any future topics? I'll have to think about that. I'm not sure that it's a bit specific, I feel, and it might be something we'll be better off discussing with you directly rather than in a general one. But I'll think about it and see if I can, if that will fit in nicely with anything else. That appears to be all the Q&A. Let me have a look. There's some chat here. There might possibly be some questions in the chat. First from Chris Street says, please you keep using normal units. I'm not sure which way, it's from Canada, so which way is normal units on that? Is that US gallons a minute or cubic meters per hour? David Gordillo has said, what happens in the pump if suction specific speed is higher than specified? Nothing really. The pump has been designed to operate smoothly at that suction specific speed. What you will probably find that with pumps with higher suction specific speeds, 12,000, 13,000, you may not be able to get such low flows as you would do with a pump with lower suction specific speed. They're possibly more subject to low flow recirculation in the eye of the impeller. But again, the pump has been designed for that suction specific speed, and if it's a good modern design, the designers will have taken it into account and checked things, and we would advise you of the allowable range of operation of that pump without any worries whatsoever of significant recirculation. John Hamer has said, who should I contact as I do not seem to be receiving the slides after the webinars? Thanks. Okay, if it's not working when you send to info@rawpumpen.com, then send one to me, smith@rawpumpen.com. Okay, smith@rawpumpen.com. I'll pick up on it. From Anil Bharat, session 1, 2, and 3, can someone email the link? Yeah, again, same thing. If you can send an email to info@rawpumpen.com, I will ask our marketing people to jump on this and pick it up. Rogelio Espinosa says, how much is the NPSH reduced with an inducer? Is it a percentage? No, it can be quite substantial. The question is, you've just asked, how long is a piece of string? It can be this size or that size. There's no easy answer, I'm afraid. He also asks, is it possible to estimate the head increase effect of underfiling an impeller? Again, no. Modifying impellers by underfiling or overfiling or V-notching, or there are various other techniques, make slight differences to the shape of a pump curve. They don't make significant differences. You're not going to turn a pump that has a 20% head rise into one that only has a 10% head rise. You're talking percentage points in this. Oliver Juarez, for old Bingham pumps type MSD, do you have a cross-reference equipment to supply? I think the MSD, I thought the MSD was a BB3. So, I mean, that would be our type SM or a, yeah, I don't recall. I'd actually have to look that up to see what the old Bingham MSD was. That appears to have answered all the chat questions. Let me just go back and see if there's anything in the Q&A. If by the way, it's better if you use the Q&A rather than the chat. The Q&A, we get a record of it afterwards. It makes it very easy to do further answers, whereas the chat, it disappears. Oh yeah, okay. Some of you have asked the same question on both, so that's good, thank you. Okay, I think that's all the questions. I don't see any other new ones that I've missed. So thank you again for attending today. I've thoroughly enjoyed preparing for it and presenting this one, and indeed answering the Q&A. It's always a bit of a challenge. I look forward to seeing you all again on the 1st of July. That's 2 weeks today. So for the next short course on NPSH and suction specific speed. Thank you very much and have a good evening. Bye-bye.